Okay, let's look at exponential functions and graphs of exponential functions. Alright, so let's first look at the definition of exponential functions. Alright, exponential function f of x is equal to b to the x, where b is a constant which is positive, so it has to be a positive real number and it cannot be equal to 1. The reason why b cannot be equal to 1 is that the 1 to the any power is 1, which makes it a constant function. So we would like to eliminate that case. So it's any positive real number, but except for 1. All right. So example would be something like you can do 0.3 to the x, right? It doesn't have to be a whole number, right? Another example would be you can do if you're weird, you can use a pi to the x. That is a perfectly good exponential function. All right, b is called, this is just a terminology, b right here is called the base of the exponential function, so it's called the base. And this power, you can call it a power, or exponent of the exponential function. All right, and domain and range are fairly easy. Since we can plug in any real number we want for x, so the exponential function has a domain of all real numbers. So I'll just write it as negative infinity to positive infinity. All right. The range of the exponential function is not all real numbers. Since no matter what number we plug in here, we cannot make a negative value or 0. So therefore, our range is all positive real numbers. So starting from 0, not including 0, because you never get that, to all the way to positive infinity, right? So those are the domain and the range of the exponential function. All right, let's look at the graphs of exponential functions. All right, there are basically two cases based on the bases. Right, if the base is small, for example, between 0 and 1, right, and second case is base is bigger than 1, right. So let's look at a couple of examples where base is between 0 and 1. Right, so for example, y equals 1/2 to the x, right? So first thing is that maybe look at the y-intercept is easy one to find. Remember that the 1/2 to the 0th power, since we're looking for the y-intercept, we set x equal to 0. So 1/2 to the 0 is going to be 1. So it actually goes through 1. So which is a nice property. So y-intercept is always 1. All right, then you can see that since it's 1/2 to the x, so every time you increase the value of x, it becomes a half of the previous value. So you can see that it's going to get smaller and smaller and smaller as x value gets larger and larger. Right? So this is going to be a decreasing function. So it's going to look somewhat like this. So it's going to look like this. Right? It gets half and half, half. Right? So this is more or less the picture. Right? The comparison between 1/2 to the x and 1/5 to the x. Right? Right, as you can see that it's going to be a very similar picture, except that the base is even smaller, which means that every time x increases by 1, it becomes 1/5 of the original previous value. So it gets smaller faster, right? So it's going to be a steeper graph than the 1/2 to the x. So here's a ballpark picture. So if you look at that, it's gonna decrease much faster, right? So it's gonna look something like that, right? Right, so this is the graph of 1/5 to the x, and this is compared to that, this is going to be the graph of the 1/2 to the x. Alright, so you can see that if you have a smaller base, it's going to decrease faster. Right, and you can see that the graph is throughout the x-axis, so you can see that the domain is going to be all real numbers, and the graph stays above the x-axis, which means that the range is going to be all positive real numbers. Alright, so let's look at the second case where a base is greater than 1. Alright, so right here, here's an example where base is e. Right, here's a note. Right, note that e is just a number, so don't be scared of that letter. E just as a number, which is about 2.7. Right. Right, for now, we don't have to worry about the precise definition of the number e, but all you need to know is that e is just a number about 2.7, so it's definitely greater than 1, right? Right, so you can see that so e to the x is going to be about the same thing as 2.7 to the x. So which means that every time you increase the value of x by 1, it's gonna get multiplied by about 2.7. So it's gonna be an increasing function. So a graph of e to the x looks like this. So it's gonna be increasing function, and y-intercept is still the same as 1. So here is 1. All right. And the difference between e to the x, which is about 2.7 to the x, and 5 to the x, right? 5 is even a bigger base, so it's going to increase faster, which means that it's going to be a steeper graph. So we're going to have to graph it like this. So it's going to have a steeper graph, more like this, right? Right, so this is the 5 to the x, and this slower growing function, that's the e to the x, right? And again, even though base is greater than 1, domain and the range are the same thing. So domain is all real numbers, so you can see the graph throughout for all real numbers of x. And the range is going to be all positive real numbers, since the graph stays above the x-axis. All right, that's it. I hope that this was clear.